Hello everyone. So we are continuing our webinar series. So far we have covered many topics that are relevant for the manufacturing industry. And then one topic that was always there, but we never put enough time to discuss it, was the industrial networking. And the point is that the industrial networking is present in every single application, whether it's a small machine or a whole production line. Therefore, I think it deserves to cover it properly from top to bottom. So today I have a special guest, John Browett from the CLPA organization, who is joining me. And we will be discussing how the modern industrial networking is done in manufacturing companies. We'll be talking in details. So John, welcome to the webinar. And maybe you also find a couple of words to explain what CLPA is. I think it's important that our audience knows you, but also the organization that you're working for.
Thanks, Piotr. It's a pleasure to be here. So, the CC Link Partner Association. So this year we're celebrating our 25th anniversary. And so I think that shows a lot about how established the CC Link technology is. And we're proud to say that right now we have over 400 different companies that are making products that are compatible with our network technology. We've got an installed base globally now of somewhere over 43 million devices. So that shows how well accepted and how strong the CC Link technology is worldwide.
So, of course, we'll be looking at specific technologies, but I believe that many of manufacturing challenges in terms of communication are very common. So obviously there are certain problems that manufacturers have to face in that field. And I think that this is something we can discuss in detail today. So maybe I will start with a question that maybe puts those things into perspective. As I said, the industrial networking was there for a very long time, and there is a lot of technologies. A lot of companies still work on, for example, serial communication and so on. So why the industrial networking has become such an important topic in recent years?
Okay. Yeah, well, you're right. Over the past 20 or 30 years, networking in industry has become a bigger topic. And we started out back in the 1980s and earlier with, I guess you could say, discrete wiring, where there really were no networks. And then around that time, that's when the first field buses started to appear. So things like the original CC Link, which was an RS-485 based field bus. And then sometime after that, we started to see Ethernet appear on the shop floor. And so you got technologies like CC Link IE, industrial Ethernet. But where we are now is we now have CC Link IE TSN. So basically what that's done is it's addressing the challenges of modern manufacturing and the data volumes involved. And so the two key benefits that offers is it's got gigabit bandwidth. So it has tremendous capability to handle this sort of tidal wave of data that we're seeing now. And also it's got time-sensitive networking, which means that this gives you the ability to have what we call a converged network architecture. And what we mean by that is the ability to combine multiple different types of network traffic together. So whereas in the past you would have had separate networks for different types of traffic like safety, I/O, motion and so on, now we can combine all that together on one network. So that offers a lot of benefits in terms of cost saving and simpler engineering and troubleshooting and so on.
And I think that this is some topic that became a little bit tricky these days, because from one perspective you are expected to have very distributed control, right? So to have machines taking almost like autonomous decisions, so having a potential to take decisions on the spot based on the data that is important to them. But on the other hand, you are hearing a lot about solutions like a single point of truth visualization, for example, where then again the expectation is that you will have a one central system that is able to collect and gather all of this information to take decisions later, right? So those are almost like two situations that are almost contradictory to itself. But then again, we are suggesting to use one network for all of those solutions. So this is what you mean by this convergence, that this is where, okay, you can put all of the data into one network essentially, but different parts of production sites can like use them differently, right? Is this the case?
Yeah, well, I think one of the challenges that we had in manufacturing in the past, and still do really in some cases, is that you saw what I guess some people have called silos. Like for example, most manufacturing plants develop over time. So you may have one shop here that was done in one time with one vendor, and then another one done some other time with a different vendor. And so maybe there's one kind of technology there and a different kind of technology here. And as a result, they don't talk to each other. And that's made having this, like as you said, the single source of truth, if you like, quite difficult, because there wasn't an easy way to get information and data from all these different places and see what was going on across the whole plant. So that's where technologies like TSN can potentially offer benefits, because they offer a way to address that by having all these different kinds of networks talk to each other in a single architecture, and therefore make it easier to see what's going on across the whole plant. The thing that we've kind of talked about at the CLPA recently is we've been kind of talking about this as though it's kind of like the plumbing, if you like, of manufacturing. The thing is, so you've got your machinery or systems on the shop floor, and they are producing a lot of data these days. As we were saying, like with the digitalization of manufacturing processes, you're getting more and more data being produced by the devices and systems on the shop floor. And so you need a way to get all that data from where it's been produced to where you need to analyze it, and then take those insights that you're getting from that data and feed it back into the process to optimize it. And that's why we're using this metaphor of plumbing, because just like in a normal plumbing situation where you've got pipes carrying water around, well, you could argue that there's an analogy here with networking. Like I say, instead of water, it's data. So you need something that can get your data from where it's been produced to where it's been analyzed and back again. And that's where technologies like CC-Link IE TSN offers significant benefits, we believe. It's giving you the ability to handle that data and move it to where it's needed and back again in the best way possible.
This and clear simplification of the infrastructure that is necessary to make it happen are two obvious benefits for manufacturing companies. But what other business reasons lay behind implementing this kind of one network technology that is then based on TSN?
Well, in the end, I think it's very easy to get sidetracked by the technology. Everybody likes talking about some kind of technical features like gigabit or TSN or whatever. But what we have to keep in mind is that in the end, all companies are really there to make money and be successful in business. And the technology is just a way to enable that. And so that's where we think the technology, in our case, provides benefits, because we think the best way for your business to be successful is to have processes which are optimized and working in the most effective way. And you can't really do that unless you know what your processes are doing and how you can improve them. And as we were saying, that's where we feel that our technologies offer the benefits, because it allows you the ability to extract that data in an easier way and therefore analyze it and then produce the necessary optimizations.
So maybe let's elaborate on the metaphor of plumbing. So it is clear how let's say, putting all of this data in motion, right, and being able to get it where it's needed, it's very important. And what does it mean for the processes themselves? So if we are talking about one network technology that is supposed to serve all of the production needs, those needs are very different from each other, right? So you will have motion control, which is a completely different application area than, for example, utilizing data for visualization or for analytics, right? Mm-hmm. So how does it work that you're actually making factory networking simplified to the point when you have one network on one cable and still you are able to realize those very different application areas?
Well, yeah, there's, I mean, I think we don't want to get too deep into the technical aspects of this, but just to kind of keep it at a higher level. So this is all really kind of enabled by using time-sensitive networking. And TSN is a relatively new technology in the industrial automation space. But really, how it does what you were just mentioning is, so you basically have a hierarchy of different priorities on the network. And then there's also technologies in the background there that make this communication deterministic. So what that means is that basically you know exactly when events are going to happen, and the data is sent across the network in a very predictable way. So you know exactly when things are going to happen. So basically what it comes down to is that the traffic on your network, which has the highest priority, so that may be like, for example, somebody hits an e-stop because there's some kind of incident, or like you say, maybe it's motion control, which typically is very, it has to have very fast response times usually. Well, TSN gives you the ability to prioritize all those different levels of traffic on the network and make them coexist in such a way that everything happens when it needs to happen without a loss of performance. So, as we said, your top priority would be things like very fast events for motion control, or maybe very important events for safety. And then maybe at the opposite end of the scale, you might have something like data that is being sent to SCADA, maybe at the end of each shift, some kind of quality data or something which is not as time critical. But the idea is by prioritizing all these in different queues in the mechanisms of the network, you can maintain the performance for all those different processes without them interfering with each other.
So it's at the end, it's all up to the time management within the network itself.
Basically, yeah.
Yeah, because the one thing is to have kind of like a predictable information on when the data will come or arrive at the specific point. But the second point is to actually have a milliseconds response that is necessary, for example, for safety applications, right?
Yeah.
But this is managed within the network due to the TSN specification itself.
That's right, yeah.
Good. So maybe let's discuss now the CC-Link ITSN itself. Mm-hmm. So the network technology that definitely we as Mitsubishi Electric support in pretty much all of our components. We use it across very different applications. So maybe let's discuss the specification of that network and how it differs from the existing standards, let's say.
Okay, well, yeah. I mean, first of all, I think it's important for us to say that we really appreciate the support that Mitsubishi is giving to our technology. Mitsubishi is a very strong supporter of the CC-Link Partner Association and also one of our board members, so we appreciate all that support.
Yeah, and as I said, so we support pretty much all of the components with CC-Link connectivity, and that means that you can build an entire application based on this specific network. Let's say that we are using the same type of equipment, same components for a given machine. What would be the difference between this machine running on CC-Link ITSN compared with a machine like from 5 years ago that is utilizing some standard industrial protocols?
Right.
How would you compare the performance of those two machines?
Yeah. Well, I think there's probably two main differences there. So the first one is, so in the past, Well, obviously Ethernet in manufacturing has been around a long time, but it's only been quite recently the performance of Ethernet on machinery and so on has been deterministic. So although you did have industrial Ethernet networks in the past, it didn't always mean that there was a very deterministic performance on the machine. So as a result, that could sometimes limit performance. You could limit how much loading you could use for your bandwidth and all this kind of stuff. So now with technologies like TSN, we have that level of determinism. So the concerns about performance and predictability and all that kind of stuff have pretty much gone away. But then the other key difference is, as we were saying earlier, probably 5 years ago, if you were building a machine, and say for example it was a packaging machine, so obviously most packaging machines are very heavily dependent on motion control. So as a result, you would have had some kind of motion control network that was handling all the different servo axes and so on. And so that would have been one set of wiring, if you like, and one set of hardware. And then obviously, you need to keep the operators and other people in the factory safe. So there would have been some kind of safety network on that too. You would have had some kind of sort of regular control network for handling I/O and so on. And then finally, depending what the machine was doing, maybe you had even things like some kind of TCP/IP network going on with Ethernet. Maybe you had, like, for example, machine vision systems that were sending video frames around to different places. So, that was several different network types all kind of running side by side on the machine. So, obviously that's a lot of wiring, it's a lot of engineering, it's a lot of cost. If you're engineering machines, it's a slower time to market and so on. If you're an operator, it's more time troubleshooting when things go wrong. But now with TSN, what we can do is we can take all those different kind of networks and we can make all that traffic coexist on the same network. So as a result, you've reduced the cost of the machine through the hardware required. You've made it easier to see what the machine is doing because the traffic is just on one network instead of multiple networks. And so in the end, you have a machine that it's easier to see what it's doing, it's more efficient, it's cheaper to build, and it's faster to get to the customer. So it offers multiple benefits.
Makes sense to me. And of course, we just spoke about like one particular machine, which is just a part of the picture, because when we are talking about the whole industrial production and having all the production lines or the machine chains and so on, the benefits are multiplying. And I think one area which deserves some explanation here is related to connecting this kind of production lines or machines to the IT systems. Right. Because these days, this kind of boundary between IT technology and the industrial networking technology of the production side is kind of disappearing, right? So how does the new technology helps in, let's say, improving that area, so the IT and automation integration?
Right, yeah. It's true, yeah. I mean, in the past, there used to be a very clear boundary between what was happening on the so-called enterprise IT level, like in the factory offices and MES systems and all that kind of stuff, and then what was actually happening on the shop floor with the machines that were actually doing the production or whatever. And part of that, I think, maybe was partially to do with how Ethernet worked in those different spaces. So obviously in the office, Ethernet doesn't have to be deterministic. If you send an email or something and it arrives 1 minute or the next, nobody really cares. And as we've seen already, that's not acceptable for production machines. So yeah, there was maybe this misfit between what the office was doing and what the shop floor was doing. Well, now with technologies like TSN, we have the ability to make that data not just flow more easily around the shop floor itself, but also make it easier to share it with the office level systems. So once again, TSN is a technology that isn't really restricted to what machines are doing. It's also, it can work at multiple levels of the hierarchy too. So yeah, you're right. This means that as we talked about in the beginning, you've got your higher level systems, which maybe are actually taking the data from the shop floor and figuring out what's happening and how to do it better. And TSN is a way to get that data to those systems, and then the insights they produce back again, so that, as we said earlier, once again, it helps to optimize everything.
Yes, and I think, in the past there were also different expectations, or they still are different expectations from data. So, for example, the production data had to be deterministic, and then in case of the data that goes to the high-level systems, not necessarily. It could be slower, and it wouldn't need to be delivered like in a very timely manner. But now, because also the big systems, the IT systems are used often to do some reasoning and actually take decisions about the production, also this data, let's say, speed on the office level is increasing. But we will talk about it as well later on. Mm-hmm. But the one thing that comes to me right now about all of what you just said. So I think a big difference and a big trend that we see in the industrial networking is that those volumes of data seem to be growing, and growing very fast. Mm-hmm. Because let's say that this is the one cable network that you need, and there is nothing else you need. But in that one network, you will have a very, very deterministic motion communication. In the same time, you will expect a big chunks of data to flow to high-level systems, right? Mm-hmm. So naturally, it seems that the potential problem is the capacity of communication. Yeah. So how is this solved?
I think, again, that's a very important point. As you said, as manufacturing is becoming increasingly digitalized, as we say today, the ability to handle more and more data is becoming more and more important. And in the past, and even still today to some degree, a lot of people are still kind of making do with fairly limited bandwidth. For example, some people are believing today that 100 megabit bandwidth is sufficient for what they need. And that was probably true in the past when the volumes of data being handled in manufacturing weren't so big. But as you said, now even just like a photo eye or something on a machine, in the past it basically said it was on or it was off. But now you get photo eyes now that they can tell you if the lens is dirty, if it's not facing the right way, or all kinds of other parameters they can tell you rather than just on and off.
And that's just one sensor, right?
Exactly, yeah. So when you start thinking about that, and that's just a very simple kind of sensor, but when you think about how you get more sophisticated devices, if you look at a lot of, like, for example, inverters or servos now, some of them have literally hundreds or maybe even in some cases thousands of parameters that you can adjust and play with to get what you want. So it's very easy to see how this data has gone from being a sort of trickle to a huge wave. And so as a result, the 100 megabit, maybe it was a pipe like this, but you've got this big wave of data coming at you. Well, now it's very clear to see you're going to need a bigger pipe. And as a result, this is why, with CC-Link IETSN, we support gigabit bandwidth. So that, that's about 10 times more bandwidth than most people were using in the past with 100 megabit. And as a result, this is providing significant benefit because, as we said, all these different devices producing all this extra data. Now you have the bandwidth to deal with that, and you don't have bottlenecks. The performance is maintained. You're not slowing things down, and so on.
So I believe that what we have covered so far is very much related to how this new technology can actually transform the existing type of applications, right? Mm-hmm. So we are talking about motion, connectivity with high-level systems, this kind of areas. And maybe just to summarize this part of our discussion, maybe we can talk about a specific story from the industry. So maybe you can give us some example how CC-Link IETSN was used in a specific machine, and how did it transform the operation of that company? Well,
actually, I can actually probably give you 3 different examples at the moment, just very quickly. So the first one was is a company called Keller. and they're in Poland, and they make very sophisticated machines for doing printing. And but this isn't like newspapers or magazines or something. It's actually printing onto objects like shampoo bottles or something. And so they make these huge, very sophisticated machines that have, in some cases, maybe more than 60 different motion axes in them. Very, very large scale, very sophisticated machines. And they're basically using CC-Link IE TSN to handle all of that motion control on one network. So you've got all this high performance motion control, very many axes and so on. But at the same time, you've also got all the general operation of the machine going on at the same time too. So, you know, that's a good example of how you can use a converged network to do that kind of thing. Another one is there's a company in Spain called KFT, and they make machines that basically, when you go to the supermarket and you buy, say for example, sliced meats, they come in a nice plastic tray and they're all nicely laid out and so on. Well, they make the machines that do all that kind of slicing and so on. And in a machine like that, so again, you've got all different kinds of control going on, but they've actually got several different kinds of pneumatic control going on, as well as their normal control in the machine. So they've been able to take a system where, you know, CLPA's got many different partners, and as well as Mitsubishi, one of them is the pneumatics company SMC, and they've been able to take pneumatic valves from SMC and other pieces from Mitsubishi and so on, and they've been able to again integrate them all onto one network and one machine. And then the final example I could say right now is, so in Germany, there's a company called Hambi, and Hambi, they've actually kind of produced a world first. And what they do is they make very large scale machines that produce the steel mesh that goes inside reinforced concrete for construction. Machines that can produce this mesh in many different ways to suit the needs of the building that's been built. But again, they've used CC-Link IE TSN to handle a lot of different axes, because there's a lot of motion control going on to like have grippers that handle the mesh and the wire and connect it together and so on. And on the same application, they've got things like vision systems that are looking at the mesh to make sure it's in the right position and so on. And again, they're using this converged network technique and technology to simplify the construction and the operation of their machines.
Yeah, I didn't think about the visual inspection part, right? So actually these days in production sites you will actually have a lot of visual data that also somehow has to travel from one point to another. And that is another example how this kind of TSN can support such advanced applications, right? So
yeah, absolutely.
Without disturbing any other type of communication, you can still send the live video feed or the pictures, right? Yeah. So this is very, very important.
Yeah, absolutely. In fact, at CLPA, we actually have a demo that we use it at the different fairs we do, the different trade shows. And it demonstrates exactly that concept. So we've got a system where you've got motion control axes and you've got I/O traffic and so on going on the network, but at the same time you actually have a machine vision system, which is from one of our other partners, Cognex. And you can see there's a monitor there, and you can see the video frames that the monitor is displaying from the camera, and these frames are going across the same network as all the automation process data as well, and everything's functioning together on the same network without getting in the way of each other. Yeah. So that's a good example of that. And in fact, actually, if you go to our YouTube channel, you can see a video that shows all that and all the different things involved with it.
Good. So that makes a lot of sense, and I think that these examples are actually quite good to explain the difference. So that would be okay for me. But there is actually one topic that I think we should spend a little bit time on as well. And for me, this is data analytics. Mm-hmm. The reason is that obviously these days you see more and more demand for analyzing the production data and actually making very sophisticated type of analysis, right, often. Yeah. So here we are talking about, of course, different approaches, different applications, but Normally what you like to have is take all of this relevant data, which usually is a huge volume of it, and then either place it in the high-level system for deeper analysis, or even sometimes doing the analysis on the edge to make decisions quicker, right?
Yeah.
So all of this in the recent years have become really, really important for many manufacturers,
Right.
especially the ones that want to, use this for the competitive advantage, right? Quickly analyzing data, taking decisions on the factory floor, responding to changes in demand, in the production situation, and so on. So I think that even from this perspective, this data that is in the factory is gaining significance. So I would like to understand how the TSN technology or CCLink ITSN in particular are supporting this kind of, let's say, almost like a new business function, which is data analytics, especially the data analytics that is has to happen in a certain time frame.
Well, I think it kind of goes back to what we were talking about earlier. There's the analogy here of how you have the so-called plumbing of digital manufacturing, but it's not water that's moving around; it's data. And again, that's exactly where CCLink IETSN comes along. It makes sure that you've got the pipes that you need. Pipes, obviously, is a metaphor, is not really pipes, but it's making sure that you've got the ability to take that data from where it's being produced to where you need to analyze it and back again. And I think an analogy you could use to take this a step further is you could consider how your higher level systems, whether it's AI or something, is kind of a bit like a bathtub. So if you think about it, a bathtub, if you can't put water in it, it's not much use. And so you could argue an AI system is similar in a way. You need to fill it with data for it to do what it needs to do. So here at the CLPA, with technologies like CCLink IETSN, we're actually enabling you to get your data into your system to make it do what it needs to do and then get that result back again. So again, it's kind of like you're filling a bathtub with water. Well, now we're filling an AI system or whatever it might be with data. And really, in the end, that's where we're actually kind of supporting the trend towards digitalization and supporting the trend toward these kind of systems.
Although in data analytics or analysis, so what also is very, very important is, when certain things happen, right? So actually there is the time aspect is crucial here. And since the data in TSN network is, put in order, in the order of the priorities and so on, but still you are able to quickly identify each data timestamp, right?
Right.
Would that be something useful from the perspective of data analytics?
Yeah, I think so, because obviously, especially in high-speed processes, you need to be able to understand. Say for example, there's a problem in the process, something keeps breaking or something isn't happening right, and the quality is low. It's very important to be able to figure out what's happening when, and what sequence of events and so on you've got going on, so that you can try and figure out what the problem is and how to address it. And like you say, by having things like timestamps and so on, enables you to say, okay, we know that happened then, and we know this happened then, and so on. And by looking at that, we can go back and analyze it and figure out what the problem is and what we need to do about it.
Yeah, because at the end, any high-level system kind of assigns the time when the data arrives to it, of course. But here the advantage is that you are getting the exact time when something happened within the network, right? So for any type of troubleshooting of any errors, I think this is extremely important, right?
Absolutely, yeah.
So I think that one more thing that we could discuss is the future of industrial networking, because I think TSN, okay, it is not brand new. I mean, the standard, the TSN standard itself was established some time ago.
That's right.
However, the TSN technology to be actually adopted in manufacturing companies on a bigger scale, this is actually just starting, right? So we see some, of course, many applications already, but those are still early adoptions of this TSN specification, right? What do you see happening next? So like, what is your projection regarding the future of industrial networking?
Well, I think one of the key things that are happening at the moment, which is going to have a big influence on the future direction, is at the CLPA, we're working together with several other organizations in the industry. And we're all working together in an organization called TIAC, T-I-A-C-C. And basically what TIAC is all about is producing common ways to certify TSN devices so that, when you're building a machine, you'll have a broader choice of different vendors to choose from that are using TSN technology, and you'll know that all these different devices will work together. So, and that's being worked on right now, and we're expecting that to be ready in the near future. So that will help to accelerate the adoption of TSN in industry. Really, like you said, although TSN has been around now for many years, I mean, it didn't start in manufacturing, it actually started in professional audio and broadcasting, believe it or not. But it's very clearly established and very well established in manufacturing now, and with these initiatives like the IEC and TIAC and so on, we can see that that's going to continue and it's going to accelerate and become more widespread as we go forward.
Also, I think that one area which we see developing very much is the edge computing, mostly due to the fact that a lot of decisions in factories, like companies want to make them quicker. So they don't really want to rely on the latency of the, any type of cloud system. So of course, cloud-based analytics is probably having much higher performance, and maybe you can analyze bigger volumes of data and quicker and so on. But when it comes to quick decisions on the factory floor, the edge computing is actually growing in significance.
That's right.
So is this something which you think might drive the future of industrial networking as well?
Yeah, I think you're right. We've been talking about plumbing and bandwidth and all those kind of things, and getting things to higher level systems like cloud-based systems. But you're right. A lot of companies don't necessarily have their own cloud. They're using some third-party cloud, and as a result, that may mean there are latency issues. So therefore, if you're using edge computing or edge servers or something, you can address that by using those. And not only that, but I think also a lot of people realize that although there's this huge amount of data on the shop floor, not all of it is actually that interesting or necessary. So, another important part for the edge computing piece is to try and sort of filter and prioritize things so that only the important stuff is being looked at. So yeah, that's definitely something that factors into it all. But I think the other thing that's an important issue too when it comes to cloud computing and cloud services is this is a topic that's becoming more and more important, I think, as time goes on. But the whole topic of data sovereignty, a lot of companies and people now are looking at the fact, our processors are producing this data, but where is it going? Where is it stored? Who's looking at it? And all that kind of stuff. And in many respects, companies are starting to realize what the value of that data is, and it represents possibly proprietary information about their processes and so on. So as a result, I think it's also important to be aware of where this data is going, where it's been stored, and so on. And like you say, maybe there's a role there for edge servers to play there too, to make sure that you're not sharing data with somebody who shouldn't be looking at it, possibly.
Especially since security breaches happen, and there are incidents involving big cloud providers as well, right? And if your whole factory is relying on one network, I think it's very important that this network stays in the factory.
Right, yeah.
And this is probably where the edge level computing is helping a lot, right? Because the edge is actually, still physically in your factory. And then, yes, you can only let certain data out of it, right? So I think that this is something which, generally speaking, cybersecurity will be another big development trend in future, right?
Yeah.
How do you assure the security of your data, right? And for sure, in this case, we need to consider also other components, right? Not only the networking itself, because actually you can get into the network through different components, right? So this is where probably there will be a lot of developments. But still, I mean, clearly the cybersecurity is a trend to also drive the future of industrial networking.
Yeah,
right?
absolutely. Yeah.
Good. So for me, this was very, very interesting, but I think that we covered, from my perspective, all the main implications of using the new type of technology based on TSN. So maybe you would like to summarize this conversation in a couple of words, and then we conclude our discussion.
Well, maybe not just 2 words, but I think as far as we're concerned, the 2 key concepts, the 2 key takeaways from here is one is the time-sensitive networking. As we said, that's going to become a bigger and bigger trend as time goes on. And the other one is the gigabit bandwidth, the ability to deal with all this data and have the capacity to handle it. So I think from our point of view, those are the 2 key takeaways. And I guess actually, now we mention it, the third takeaway, of course, because we're the CLPA, is that this is an open technology. So, as well as Mitsubishi being heavily involved, we've got, as we said earlier, I think there's about 400 other companies who producing products compatible with our technology. So, there's a very big ecosystem out there and very big choice for different devices and systems and products and so on that all work with this technology.
Great. So I think sooner or later we'll meet again and we'll discuss, let's say, where the TSN is as of now. But I'm sure we can expect more and more applications like that. So thank you very much, John. It was a pleasure to having you here.
Thanks very much. Thanks for the opportunity.